Lesson 8.5 is adding and subtracting rational expressions. We did example A in the adding section. And remember, what's the key in order to add these two rational expressions?
Common denominator.
Common denominator, right? We're adding fractions, basically. So we have to have a common denominator. So as we look at B.
We started it.
We didn't start B.
Nope.
I maybe mentioned something like that.
We factored it.
Oh, did we?
Yeah, we
Oh, well. Okay, so as we talk, I don't remember it, but that's all right.
I have
Regardless,
plus 2x minus 2.
as we talk about B, before we get a common denominator, we need to factor the denominators, yes? So that has got to be step 1, is factoring the denominators. What do you know about x squared minus 4? Whether we talked about this yesterday or not, I don't know, but x squared minus 4 factors into two parentheses, x and x. The square root of 4 is 2, so we're doing 2 and 2. And if it multiplies to be negative, plus minus. So x squared minus 4 is going to be replaced with x plus 2 times x minus 2. What about my second denominator, x plus 2? Does it factor?
No.
No, it does not factor, but I've at least checked. So now we're ready to work at getting a common denominator. So my questions to you, what do both fractions have in common? X plus 2, agreed. Both fractions have an x plus 2. So that means x plus 2 is part of my common denominator. Anything else that both fractions have in common? They don't have any other factors in common, do they? They just have the x plus 2 in common. What about leftover factors? Not x, but they have a factor of x minus 2 here. So we also have to include x minus 2 in our common denominator. So our common denominator is going to be x plus 2 times x minus 2. X plus 2 represents what is in common. X minus 2 represents leftover pieces. Now, as I look at the first fraction, any differences between the original denominator and my common denominator? My original denominator was factored into x plus 2, x minus 2. My common denominator is x plus 2, x minus 2. So does anything on this first fraction need to change? No, because I've already got the common denominator. So this x is just going to carry down. Okay, nothing changes. Second fraction. My common denominator is x plus 2, x minus 2. What was my original fraction? X plus 2. What's missing from the denominator on this second fraction? An x minus 2. So we're going to multiply this fraction by x minus 2. If I multiply the denominator by x minus 2, you're going to multiply the numerator by x minus 2. And so that second fraction, numerator, on top there's already a 1, and I'm multiplying by x minus 2. What is 1 times x minus 2? 1 times anything is that other thing, right? So 1 times x minus 2 is just x minus 2. Okay. We have a common denominator now, yes? So I'm ready to add these fractions. I'm going to put them together as one fraction. My common denominator, I'm just going to rewrite as x plus 2, x minus 2. As I think I mentioned yesterday, I don't multiply my denominator together unless I have a reason to. Okay, usually we leave it in factored form. Okay, now we're adding. How do we add our numerators here? We have x here, plus, we're adding it to an x minus 2. Are there any like terms I can actually add? X What is x plus x?
X squared.
No. 2x. 1x
Yeah.
plus 1x adds to be 2x. So that takes care of x plus x. And then what else do we have? The minus 2. So 2x minus 2 over x plus 2 times x minus 2. Now, you might be done at this point. You might not. Just kind of depends. Always factor your numerator to check and decide. Does 2x minus 2 factor? Or maybe I should say, how does it factor? There's a GCF there. 2x minus 2, GCF of 2. So in my numerator, I'm going to factor out a 2. When I factor out the 2, 2x divided by 2 leaves me with x minus 2 divided by 2 leaves me with 1. Over my original denominator of x plus 2, x minus 2. What factors cancel? None. My final answer is 2 times x minus 1 over x plus 2 times x minus 2. Like normal, I can't speak on behalf of Math Excel. However, because nothing canceled, if you looked at that in your head and you realized nothing canceled and you left it as this previous form of 2x minus 2 over x plus 2x minus 2, that is acceptable for me. Math Excel, I think it might be acceptable for Math Excel, but I'm not sure. However, we need to make sure nothing cancels, right? Because yesterday on example A, we factored and something canceled, didn't it? Today, we factored and, oh, well, you factored. Nothing canceled, though.
What did you divide to get the one? I know it's 2 2's, but which 2 2 you divided?
To get this one?
Yeah.
So I was factoring out GCF of 2.
Okay.
So the original term here in that place was 2.
Mm-hmm.
So 2 divided by 2
Okay.
results in 1.
Okay.
Is that what you need to see?
I just wasn't sure where you got both the 2's from.
Okay.
Once we find the common denominator, we can't use it from both sides. We just set it as 1. Like, because I know you had to split it up into 2, like with it on both, but you can divide it into 1. I just use one of them. I don't have to use both.
In terms of when I go to here?
Yeah.
Right. Because it's just like, go back to the basics here of 3/5 plus 1/5. When we have a common denominator, you add the numerators. 3 plus 1 is 4, but the common denominator of 5 just stays. So it's that same idea. It's just harder for us to see when I talk about factors, isn't it? Which is why, does that help make more sense? That's why I keep going back to, I know we're not necessarily fans of fractions, but this is what I keep going back to. Okay?
So it's something easy made complicated.
That's just a more complicated version of dealing with fractions. Now, I'm not quite done with problem B because we didn't do our restrictions on the variable. In order to do restrictions, we set the denominator equal to 0. What's in the denominator there? Yeah.
X plus 2.
After you get that common denominator, use any part of that common denominator, okay? So x plus 2 equals 0, x minus 2 equals 0, so x cannot equal 2 or negative 2. I went the fancy route and said plus or minus 2.
I was gonna ask if you could.
You can do plus or minus 2. Math Excel should accept plus or minus 2 as well. You don't have to, though. You can use a comma. Okay. We've seen a second adding example, right? And I know it's still a little rough, but I want to make sure we get through several. Can I skip down to a subtracting example? I want to make sure we don't run out of time for stuff today. So, and here's the deal. Is subtracting going to be a lot different than adding?
No.
No. You just have to make sure you subtract your numerators. So you just have to, watch out for signs when you're subtracting that second numerator. So let's go ahead down to the next part. And I want to try and get A and B here. We'll see what happens. So, example 2 is find each of the following differences, and again, state restrictions on the variable. We're still doing the exact same thing, guys. One small different step in the middle as we subtract. Other than that, this exact same stuff. So, in order to subtract fractions, again, you need a common denominator. In order to find out a common denominator in this situation, we need to think about factoring. So, x squared minus 2x. Does it factor? How does it factor? Not x and x, 2 parentheses.
GCF of x.
GCF of x. And here's how I know. Both terms have an x. In order to do 2 parentheses, I have to have a plain number to even consider it, like a number without x's. And I don't have that. So think GCF, x squared and 2x both divide by x. X squared divided by that x I'm factoring out leaves me with x minus, carry the minus sign down, 2x divided by the x I factored out leaves me with 2. So that first denominator factors into x minus 2. Okay, second denominator, 2x minus 4. Can it factor? GCF again. This time I don't have an x squared, so again I can't think 2 parentheses. But 2x and 4 both divide by 2. So I'm going to put a 2. 2x divided by 2 is going to leave me with x minus 4 divided by 2 is going to leave me with minus 2. Okay. Common denominator. I'm going to start with the same questions I did earlier. What do both denominators have in common? Okay, so right off the bat, we know they both have an x minus 2 in common. So x minus 2 is part of my common denominator. Anything else in common? No. Okay. Leftover pieces. Do we have leftover pieces here? Yes. What kind of leftover pieces do I have? I have a leftover x out here, and I have a leftover 2 out here. So that means an x is going to be part of my GCF, and a 2 is going to be part of my GCF. When I write this, x times 2, how do we usually write x times 2? We usually write 2x. So I'm going to write my common denominator as 2 times x minus 2. Or, more simply put, 2x times x minus 2. But when I say 2x, that is 2 times x.
I don't both of them get it. Like on the top one we did x minus 2 on both of them. Or x plus 2 on both. Why don't they both have x minus 2?
Well, are you talking about right here that I haven't filled in yet? I'm getting ready to fill in.
Okay.
Yeah. So, yeah, no, okay, sorry.
No.
What I was getting ready to do there is fill in my common denominator on the second one. I was trying to figure out my common denominator, and then I was going to fill
So
it in.
they'll always be the same.
Yes.
Because
Right, yes, your common denominators, that's the whole point of common denominators, is they should be the same. Otherwise, you're doing something wonky there. Okay. Ready? As we look at my first fraction, my denominator, original denominator was x minus 2. My common denominator is 2x, x minus 2. What is my first fraction missing in the denominator? A 2, yes? So in order to get the common denominator, I have to multiply my denominator by 2. If I multiply the bottom by 2, you have to multiply the top by 2. How do I multiply 2 times x plus 2? You're going to take this and you're going to distribute, right? You guys handle if we go ahead and do that now? 2 times x plus 2, I'm going to go ahead and multiply it, save us a step later. 2 times x is 2x, plus 2 times 2 is 4. Good enough? Same type thought process on the second fraction. What is my denominator missing from the common denominator? X, right? It has the 2. It has the x minus 2. And I'm just going to kind of tag it on back here. It's missing an x. So what do I have to do up here? We have to times x. How do we multiply x times x plus 2? Just like previous. Distribute. What is x times x? X squared plus 2 times x? 2x. Okay. We have a common denominator, yes? So we are ready to subtract fractions? Okay. Let's subtract fractions then. As I put this together, what do we know our denominator is going to be at this point?
2x.
Okay. 2x times x minus 2. You just keep that same denominator. Now, what type of problem is this? Subtraction, right? I'm trying to get you guys to look right here. That's a subtraction sign. So as you subtract, anything on this second fraction is being subtracted. So what do you guys see? 2x does what? Subtracts with the other like term of 2x. What is 2x minus 2x? 0. Gone, right? Don't need to write it down. Okay, what about 4? What's 4 subtract with? 4 minus nothing is 4. Okay. 2x canceled. I took care of the 4. Am I done?
No.
No, there's still a x squared. It didn't have a like term up the front on the first fraction. What about this x squared? We're going to drop it down, but what's being done with the x squared since it's on the second fraction? It's being subtracted, right? So it's going to be minus x squared. It's being subtracted from nothing, but 0 minus x squared is negative x squared. So I'm going to write that numerator as 4 minus x squared. Okay? Now, that's kind of your beginning answer. But what do I keep telling you guys we need to do? See if anything factors, right? So, in order to see if anything factors, one thing I would consider, and I might have did I just hear something about it? What about this numerator? Do we like 4 minus x squared? Usually you guys aren't crazy about that one. So, and I'm just going to write it right up here, but if I flip it, as in reverse it, so that means that if I put my x squared term first, and then my 4 term, this is really going to be negative x squared plus 4 in my denominator. And that's important to me. I have this set up on my notes. Okay. Negative, if you think about negative x squared plus 4, what am I going to encourage you to factor out there? Because my lead term is negative, I'm going to encourage you to factor out a negative, or as in a negative 1. And this, I'm leading somewhere with this if you give me a moment, okay? So if I factor out a negative here, negative x squared becomes what? Positive x squared. Plus 4 becomes minus 4. Do you see my reasoning for factoring out a negative? Because what do I have in the parentheses now? X squared minus 4, right? So, okay, my denominator I'm just going to copy as is for the moment. 2x, x minus 2. And we got one more factoring step, folks. Denominator stays the same again, 2x, x minus 2. The negative is going to stay out front as a negative. What about x squared minus 4? Do we recognize this? Two parentheses. Excuse me, difference of squares. X squared minus 4 factors into x and x. The square root of 4 is 2. If you multiply to be negative 4, we're going to have a plus and a minus. Was there a point to doing all that factoring?
Yeah.
Did something end up canceling? Yeah. We found something that cancels. What cancels? Okay. X minus 2 cancels with x minus 2. So if you don't cancel that, you're not going to get full credit. Math Excel is going to give you no credit. You know how Math Excel is. There's no middle ground for them. So, what remains?
Minus x.
The minus of x plus 2 over 2x. I'm going to leave my answer as that. You could also say your numerator is negative x minus 2. That would be equivalent. Okay. What do we still have to ask ourselves? Restrictions on the variable. At least Math Excel reminds you of that, right? Denominators equal to 0. What denominators, how are we saying our denominators equal to 0 here? X minus 2 definitely gets set equal to 0, yes. And I would just think of my other piece as 2x. Setting 2 equal to 0 by itself, 2 equal to 0, 2 doesn't equal to 0. It's just a whole number. So it's the variable pieces that matter. But what I would say is, okay, 2x equal to 0, x minus 2 equal to 0. Well, in the 2x equal to 0, divide by 2, and x cannot equal, what's 0 divided by 2? 0. And then on x minus 2, you guys know, add 2. And so x cannot equal 0 or 2. Okay. Let's talk about B. Does it matter? I don't think it matters here. Okay. Have we done these yet? You know where to start? In order to subtract these fractions, we need a common denominator, which means we need to factor. X minus 2, does that factor? No. X minus 2 is x minus 2. What about x squared minus 3x plus 2? Does that factor? Yeah. X squared minus 3x plus 2 factors into two parentheses. X squared is x times x. What multiplies to be 2, that last number? 1 and 2. And then if it multiplies to be a positive 2, that's same signs. If it adds to be negative 3, they are both negatives. Is it a surprise that x minus 2 is one of our factors here and it's also the other denominator?
No.
No, it's more like expected. I'd be surprised if it didn't happen. Okay. So, thoughts on what my common denominator is going to be.
X minus 2.
Okay, so what's in common between the two denominators? X minus 2, so x minus 2 is part of my common denominator. Anything else in common? No. Any leftovers? In terms of leftovers, there is a x minus 1 that hasn't been used. So my common denominator is x minus 2 times x minus 1. Ask yourself, what's your first fraction missing? My first fraction had the denominator of x minus 2. What do we need to get to the common denominator? X minus 1. So I'm going to multiply by x minus 1. If I multiply the bottom by x minus 1, I'm multiplying the top by x minus 1. How do I multiply x minus 1 by the x plus 3 that's already there? Distribute? FOIL it? Depends on which word you want to use there. So let's FOIL. X times x is x squared. X times 3 is 3x. I'm going to hold that 3x for a moment. Negative 1 times x? Negative 1x. So what's 3x and negative 1x? 2x? 3 minus 1? And then last, negative 1 times 3 is negative 3. So that numerator is x squared minus 2x minus 3. Second fraction, my original denominator is the common denominator, yes?
Mm-hmm.
So that means 6 minus 7, 6x minus 7 just drops down. We're ready to subtract fractions. These fractions already have the common denominator. So as I go to write my answer, I know my denominator is going to be x minus 2 times x minus 1. Stop and check every time. What type of problem is this? Subtraction. I know it sounds silly, but it's so easy to make a careless mistake there and add instead of subtract. Okay, subtract with me. X squared subtracts with
6x.
no other x squared term, so x squared just carries down as x squared. 2x subtracts with 6x. What's 2x minus 6x? Minus 4x. Negative 3 minus negative 7. It's negative 3 minus negative 7? Nope. Becomes negative 3 plus 7, which is positive 4? Something like that. 10, negative 10, 4, negative 4. You know, one of those.
Close enough.
Yeah, close enough.
Maybe 13.
One of those numbers.
I think it's 13.
Okay. Now, this might be our final answer. Or what might we need to do? Factor. So,
Are we doing C?
we are not doing C if you need that space. Feel free to use it. Okay. X minus 2, x minus 1, the denominator stays. What about x squared minus 4x plus 4? Does it sound like it factors?
Yeah.
Looks like it should factor into 2 parentheses, doesn't it? X squared is x and x. What multiplies to be 4 and adds to be negative 4? 2 and 2. If it multiplies to be positive and adds to be negative, they are negatives. So negative 2, negative 2. Oh, hey, guess what's happening? Okay. An x minus 2 cancels with an x minus 2. What remains? Okay. X minus 2 over x minus 1. Why am I not canceling these x's? They're added and subtracted with the 2 and the 1. Okay? Don't forget, restrictions on the variable. How is my variable restricted here? X cannot equal 2 and 1. So I set both pieces of the common denominator. X minus 2 equal to 0. X minus 1 equal to 0. X cannot equal 1 and 2.
Does it matter what way you put it?
Does not. Does not have to be numerical. Does not matter. Okay, guys. Common denominators adds a twist in things, okay? This is definitely probably the harder section that we've, working on. You just got to keep working on the process, okay? Now, we are skipping C. I do want, my goal is 2 examples on back. Okay? Now, the back, and I'll flip there in a moment, but it's complex fractions.
Ew.
It's complex fractions because
There's fractions and fractions.
it's a rational expression that has at least one fraction within the fraction. So, exactly, fractions within fractions. The fractions within fractions, it looks scary,
It is scary.
but it's just a process, okay? And I'm going to go through that process with you. You'll notice here it says to work with complex fractions, look at all the denominators within the problem, and multiply top and bottom of the fraction with their common denominator. In other words, our step 1 is going to be, let's get this so we don't have fractions within fractions. And the easiest way to do this so we don't have fractions within fractions is to get rid of all the denominators. So, as we look at A, 1 over x plus x over y all over 1 over y plus 1. Fractions added on top over fractions added on bottom. Yeah, it's a mess, right? Okay, so look at all the denominators. What kind of denominators do we have? There's a denominator, well, denominators within the denominators. There's a denominator of x, there's a denominator of y, there's another denominator of y. If we think least common denominator for a moment, what would be between those pieces we just mentioned? What would be the common denominator? They have a y in common, right? And then, are there any leftovers? There's an x. So just like I was doing common denominator in the front, first ask what's in common, and that's y, and then any leftovers. And there's leftover x. So our least common denominator is actually going to be xy. Because by using xy, everything's included. And so what we're going to do is we're going to take the top of the fraction and multiply by xy. And we're going to take the bottom of the fraction and multiply by xy. The idea here, when you multiply by xy to each of the terms, if done correctly, we'll no longer have fractions within fractions. Okay, we won't have to worry about that. I think for visual sake, I'm going to write this out a little bit different before I multiply. I'm going to take the original problem and write it out so I can write the xy that we're multiplying there so we can have a little bit better visual. I think it'll make it easier to understand. So if I rewrite the original problem, just kind of spacing it out, 1 over x plus x over y. And then I'm going to do the same thing on the bottom, space it out a little bit, It's 1 over y plus 1. Every term is being multiplied by what? xy. So I'm going to multiply 1 over x by xy. I'm going to multiply x over y by xy. I'm going to multiply 1 over y by xy. And I'm going to multiply the 1 by xy. I'm not saying you'd have to write out like this, but this is the visual I think that helps. Now, I'm multiplying this xy by a lot of fractions. How do I make xy a fraction? How do I make anything a fraction? Over 1. Okay. Work with me here. Xy over 1 times 1 over x. What happens there? Think cross-canceling. I know you guys aren't always fans, but it is better. If we think cross-canceling here, what happens? There's an x here with an x there that cancels, leaving what? Y times 1 divided by 1, which is just y. Okay? Plus. Now look at the next piece. Xy over 1 times x over y. What cancels? A y on bottom cancels with a y on top. What remains? X times x. And what is x times x? X squared. Because 1x times 1x, 1 times 1 is 1, but you add the exponent, so x squared. My new numerator is y plus x squared. That's a lot nicer, isn't it? Okay, same process with my denominator. Xy over 1 times 1 over y. What cancels? Y on top cancels with y on bottom, leaving me with x. Plus, what about xy times 1? Xy times 1 is just xy. Okay? These pieces are adding, so as it stands, I can't do any canceling. Is there any factoring? Technically, there is a small piece of factoring. What do my bottom two terms have in common? An x. So you can technically factor out, need that really long, an x on bottom. And if I factor out an x on bottom, what's x divided by x? 1. Plus, what's xy divided by x? Y. My numerator is still y plus x squared. Does anything cancel? The y's are being added, so I can't cancel my y's. This x squared is being added, so I can't cancel any x's. Nothing can cancel. This is one where the factoring didn't allow me to cancel anything. You could leave it either way there. Okay? You could leave it as either option. Do I have time to look at B? So my plan was A and B.
So you don't have to do the
Restrictions on the variable are not listed here. I don't remember if they are in homework or not on this section.
it's the same thing though,
Right, yeah. Same thing. Let's at least talk real quick whether we get to go through this one or not. What would be the common denominator I would want to multiply by here?
XY.
Is it xy again?
Yeah.
There's a denominator here of x, a denominator here of y, and so it is xy again. Okay, sorry, not great variety of examples there, but we will definitely talk about some homework problems tomorrow. If there's, I feel like there's usually some homework issues we need to talk about complex fractions. So, the idea here, guys, just like last time, multiplying every term by xy. On top, that just means you're multiplying x times xy. But on bottom, it's 1 over x times xy and 1 over y times xy. So we're multiplying every piece of the problem by xy. When I'm multiplying that by xy, I'm making those fractions. Okay? So if I do the math here, x times xy on top, x squared y. On bottom, an x cancels with an x, and I have y. Plus, my other denominator, y cancels with y, and I have x. Again, nothing's going to cancel. Y's can't cancel because this y in the denominator is added. Remember, it's married when it's added. You can't cancel something out of an adding or subtracting statement. And so it would stay like such. Okay, I did not plan to do C. I did not plan to do the resistance problem at the bottom. So your homework, of course, is lesson 8.5 in Math Excel. Get it done for tomorrow. If you didn't get lesson 8.4 done, you need to go back and finish that up.
No, go ahead.